All right.
The first problem says my couch has a mass of 51 kilograms. So, Elise, this one's for you. Mass of the couch is 51 kilograms.
It was like 5,000.
It's actually it says 51,000 grams.
We had to convert it.
Okay.
Which actually wasn't difficult because converting it would just mean 51 kilograms.
Right, which is what my paper says because
really
I
nice.
edited. So that might clue you into the fact that you might need to do a unit conversion on the test.
Do we need to do it though if we know that 51,000 grams is just 51 kilograms?
You'll have to put it in kilograms in the problem because to get a newton is a kilogram meter per second
Do we have to show our work trying to do 51,000?
Don't have to show
okay,
work.
cool. Okay.
But you do have to do the conversion or you won't have the proper units to get newtons.
Yeah, absolutely.
That's the key point. So, if this couch with a mass of 51 kilograms, which is 51,000 grams, needs to be moved so I can vacuum, I want to accelerate it at 0.51 meters per second squared. Ignoring friction, with what force do I need to push the couch, Elise?
26.01.
Okay, so how did you do it?
51 times 0.51.
And you got 26?
Yeah.
0.01.
And did I give you directional information?
You said across the room.
Okay, I said to push the couch across the room. So that force is a vector quantity. It has to have directional information. If I didn't tell you a particular direction, you just need to write across the room. So if you're pushing in that direction, you need to write across the room. All right. So,
Do you want me to read it?
Jenna, will you read it because it's your problem?
Okay.
Listen.
If we consider that the friction between the couch and the floor is 30 newtons, what is the total force with which I must push the couch to accelerate it in the above problem?
Okay, we consider the friction between the couch and the floor is 30 newtons. So now what do I need to do?
Don't you need to subtract 26.01, like subtract 30 from that?
Okay, so if we remember our equation is this.
I thought you had to like add it because it was you have to push it with more force.
I thought we were solving for static, so it's static minus 30, and that would equal 26.01. So it would be 56.01 minus 30 equals 26.01.
Okay, so in the first problem, we ignored friction. We just said that. But is ignoring friction going to give you the real and true answer in real life?
No.
No. So we need to calculate the true force with which we need to push. So the real force is going to consider friction, okay? And that is mass times acceleration. Okay, so if we did that, we'd still get this same thing here, the 26 newtons, but we'd have to consider that we have to use an additional 30 newtons to overcome friction. So, with what force would you actually have to push if you consider friction?
So you did 26.01 take away 30? Is that right?
This.
Okay.
I thought it was
26 newtons.